Hi, in this video I'm going to apply power to this PCB and get into testing. This has been a long time coming. Let's get right into it.
Hi, my name is Adam. I'm building a 16-bit computer from scratch. I hope you'll join me on this journey.
Okay, I wanted to come into this test with a bit of a plan on everything that I need to actually test and confirm is working. So I put this list together. I'll stick this in the upper left corner so you can reference this as I go through each of these tests. Okay, so the first task is to apply power, make sure I don't have anything horribly messed up or one of these ICs gets hot. Now, if you remember from the last video, and I'll link it up there, I ended up having a challenge with these pins and these sockets. I don't have these sockets in yet, so I have no place that I can actually directly attach power. So I've got a bit of a hokey setup here, and my power line, which will go into my power distribution breadboard, has a clip on the end of it, which is going into a banana plug connector, which is basically jumped together into another banana plug connector, which comes over here to this little hook, which I am going to be able to hook onto the bottom pins. So hook down here, and same thing with ground. Again, a hook down here, and those two should not be touching. I don't see them touching each other. There is daylight between them. You can see with the little line on the board behind it. And so then I can pull my power rail down and apply power to that, and then connect power in one side and ground in the other. And the first time I've powered this up is now. And I get a number of LEDs which turned on, some of which are floating, which gives me a little bit of concern here that things are not quite right, but I'm feeling the ICs to make sure nothing's getting super hot, and nothing is, but this tells me I may have a short somewhere. You see how these lights are flashing a little bit, but then again it could be because I've got floating inputs. So that could be also driving this 138, which could be some of these assert lines. These are floating here, which are the line drivers which drive the LEDs. So with any hope here, with any luck, these are just floating lines and it will behave just fine. But again, after it's been on for a minute, checking the ICs, making sure nothing is heating up, I'm going to call that a good test. Okay, the next test here is to hook up all the different control lines. And off camera, before I started this, I built this test harness, and I made some notes for myself so that I knew what connected to what. The clear line, which is this very first input here on the 10-pin connector for the control lines, is actually an active high. And so I have this pull down resistor on these push buttons. The left side and the right side are connected, and then if I push the button, all 4 pins are connected together. And so this gets hooked up here into this one corner. These next two are the counter action select, whether that's load or increment or decrement or do nothing. So these go in the next two. And if you push the button, it applies power to the other side of these pins so that I don't get a transitioning state. Then I've got the AND latch pin. This is now active low, so this is tied high. I've got the assert to the swap bus, assert to the main bus, assert to ALU-A, ALU-B, address bus 1, and address bus 2, which, there it is. Now, I do need to hook up power and ground, and my power rail is disconnected at the moment. The ground connection is disconnected. No, something is not right here. Power is not connected here for the buses here. So if something is not working right. So let me figure out what's going on before I cook something. Let's start with the basics. Do I have power and ground? So that's ground, that's power. I have 5 volts. That's good. Do I have power and ground here? Let's plug this in and find out. I have 5 volts there. So if I push that, oh, there is no light for clear. Well, imagine that. So then I've got these two, silly me. Then I've got these two dip switches here. 0 would do nothing. 0, 1 is supposed to load, which would be that LED. And I'm getting nothing. 0, 2, still getting nothing. No, that was 3. 2 does nothing. 3 does nothing. Now, over here, so I've got latch, swap, main, ALUA, ALUB, address bus 1, address bus 2. So those are all working as designed. It's just now this 138, which is not working the way I wanted it to. So, where is my problem? Is my problem with my output here? I'll bring this into view so that you can see it. So I am hooked to ground here on the bottom. I'm going to test the output of the single digit pin. It is 0. When I push the button, it goes up to 5. Here it is 0, and when I push the button, it goes up to 5 volts. So I'm getting 5 volts there. And now I got to bring up the KiCad schematics. Okay, so here is that 138. Grounded down here, if I look at pin 0, I've got a reasonably low, but I don't know that it's low enough. Pin 2 and pin 3, but when I do that, I start getting some interesting results up here, which is fascinating. So I thought I'd go for the logic probe. Now, it's got power. If I touch pin 1 down here, pin 1 does not appear to be connected. If I touch pin 2, I'm getting low. If I touch pin 3, it turns on, but I'm not getting any kind of a signal. Oh, I'm getting a low signal there. So let's try pin 1 again. Pin 1 is low. So there's something going on with that signal here. I'm going to go back to my schematic. So input 0 and input 1, are these seated down good enough? That should be low, and then sliding over to the next pin, that's low. Slide up for you. So pin and pin are both low. That's good. And then when I push the button, they're still low. That's high. And that's high. So I'm getting good signals out. So my signals are good to that point. Okay, so pin 1. That goes high properly. And this is CMOS logic, not TTL logic. So let's retest that. Okay. That's good. And that has no impact on it. So I guess the question then becomes, what do the outputs look like? And I believe this is power over here. So the one next to it should be low, because Q0 should be low because my inputs are 0. And then I believe this is the other that's low. Did I wire this backwards? That would be absolutely horrible. I bet I did. Okay, so for my 138, A, B, and C, and A is with all three of them low, Y0 should be outputting low. A, which should be the least significant bit, should make Y1 go high. All right, going back. A0, which is the least significant bit, so that is, I do have that wired correctly. That should be, let's double check that, make sure I'm not lying. A is the least significant bit, so pin 1 is the least significant bit. Pin 1 is the least significant bit. So something is still not right here. Alright, let's take a look at my enables, 4, 5, and 6. So there's 4, that's low. 5 is low. 6 is high, that looks right. So my output is pin 7. And pin 7 is my highest output. So that's the one that's low, which means it's acting like all 3 inputs are low. No, all 3 inputs are high. So I've got low, low, and low. But yet that's low. I'm going to have to think on this a minute. Okay, I've switched over to the microscope now to try to see a little bit better. And is that pin floating? I mean, literally, is it in the air, as in not making a connection? And I believe that to be the case. Let me stop the video and see if I can zoom in a little bit. So I'm not able to zoom in and maintain my picture. When I'm recording, I get the full thing. This just does not look right to me. It looks like some of these pins are not making a good electrical connection, as if for some reason the pins themselves have been bent on this side. And that certainly would explain why I'm getting the output I am. And then if I push down on the pin, see, is it flex? I gotta try to find it in the video here. Let's see if I can get a good, better backing on this. Try a different device. Again, I'm going to try to push on the pin here. Let's see if I can get it focused first. I feel like my blood sugar might be dropping. That appears to flex a little bit. So I'm going to call that a bad solder job, and going to have to see if I can get that to settle down a little bit more. I'm not sure if it's going to require flux or the hot air gun. I'm going to try it with a soldering iron first and see what I can do. Now, I may have a challenge because I've got individual pins that are floating, so I may actually have to pull out the hot air to do this, which of course means I may melt everything in the vicinity around it. So I'm going to try to see if I can get this with the solder first, and then failing that, then we'll see how this works. Now with that done, I should be able to get some continuity testing done. So my ground pin is here, and this should be connected to ground pin. Let's try, that's showing connectivity, and that's from the top of the pin, so that's good. Let me get one of these wires, and that should go to going to pin 1, not pin 2. Okay, that's good to know. That is going to pin 2. I've got connectivity there. And then I should be getting, as an output, I gotta check the PCB. Alright, so the output of Q1 should also go to pin 5. Okay, so the output of Q1, which is this third pin over, should go to pin 5. I'm on the wrong IC. Okay, that looks good. One more. That's good. Alright, that's better. So now, can I redo my test here? Except I've got to flip these around. I did have those backwards. All right, let's get some electrical connections underneath. So 0, 1, load. Let's get my cheat sheet back up here. So 0, 1, the 1 is up in the up position. Load, that works. 0, 2, which is the second pin in the up position, increment, and pin selection 3 is not working. That should be decrement. Let's get this plugged back in before I try to use it. High, high, high. How can all three of those be high? It should be low. So pin 3. Did I manage to put a solder bridge in there? So let's see here. Put some flux in there. Grab a little teeny bit of solder here. Let's see if I can get pin 3 to sit down for me. Oh man, I'm bending pins again. This is not. Okay, I'm specifically looking at. Well, let's just get them all cleared up. Way I don't short nothing. Eliminate all the floating inputs. Alright, so 0, 1, that's good. 2, that's good. And 3, finally. Alright, yeah, and latch. I latched a ridiculous value, but then I should be able to, if I pull my cheat sheet down, I should be able to use 2 to increment and latch. Okay, that's bad. Well, maybe not, because, well, maybe it is. Yeah, these 4 do not appear to be working in the correct order. So somehow I managed to get these all messed up. That's even worse. That's far worse than I thought it would be. So let's do, so that was increment, 3 is decrement. That's horrible. Then I've got assert, swap, byte swap, assert. All right, well, let's see if I can get a special value loaded. Let's start with that. So if I bring in my test harness here, I can plug these into the main bus, put power here, and then if I use 1 to load and latch, let's see here, 1, 0, 1, 1, 1, 0, that's not right. Then 0, 1, 0, 1, 0, 0, 1, 0, and then this is 1, 1, 1, 0. So these really are flipped here. So 8 down to 1 are all flipped. And then I've got 4096, which I do not know if it is 5 volts or if it's a poor connection here. So let's see here. Let's go back to voltage, which would make more sense. So I'm not getting a trace over to here, but this being backwards is going to kill this board. I'm going to have to order new ones. All right, let's see if I can disconnect this and bring in my output. And let's see if it's a problem with the line driver or if it's a problem with the... So again, checking my cheat sheet here, this should be the assert button, assert to main. And I've got all kinds of problems. So again, 1011, which is what this was supposed to be, this LED was supposed to be lit. 1011, this LED was also supposed to be lit. So the question then becomes, well, there's a couple of questions that become, where is this failure? Is it just a connection problem? But this in particular is going to cause this board to be respun. Now, one of the things that's interesting is that it loaded properly, but it's incrementing incorrectly. Yeah, there's some problems here. Let's try this. Trying not to push down on the PCB and bend those pins again. Alright, let's turn all these switches on, which then if I do a 1, load, and latch, everything actually comes on. Now if I do a decrement, which is 3, decrement and latch, that light is still off. Now the question is, if I assert that onto the main bus, so main bus assert, I'm still missing some LEDs here as well, so these two are not lighting, or that one's not lighting, and which tells me the value that's stored in the register is incorrect. So let's go to the schematic. I did all of these backwards. So I think these are all supposed to be the other way around, with a low bit coming out of A. So let's go double check the data sheet. 193. 0, so 3, 2, 6, 7. So 15, 1, 10, and 9. Least significant to most significant. 15, 1, 10, and 9. So yes, I have these exactly backwards, all the way across. I blew the schematic. That's brilliant. All right, so this is the breadboard version. These are the 193s. $15. Did this ever even work? 15 was the least significant. So okay, no, I'm still fighting the fact that this is upside down. So 15 is the least significant. 15 is drug out by this green wire out to the end. This then is wired to the bit in here. So I am willing to bet that this actually never worked properly. So I had flawed testing. So that's ridiculously painful. Okay, this mess is moved aside. Turn off my soldering iron because I'm not going to make any more attempts at repair on that because it's a mess. Alright. Last connection here. Power and ground. Alright, so let's see what you can see here. So what I've got is I've got the same test inputs here, but I've got it wired up to this ribbon cable, which is distributed to the board properly. And so if I hit clear, I should have everything clear on me, and then I should be able to bring in my harness here to load. And so if I set this to be 0, 1 down here, hit the load and latch, I get nothing. Now I guess the question is do I still have to reverse these on this breadboard? So 01 is load, Okay, I got the most significant bits loaded, but nothing else loaded. The question then becomes, do I have something that's fallen apart here, other than my sanity? Okay, let's try that. So I believe these do need to be crossed over. Okay, so nothing, load, and latch. Perfect. Okay, that's working perfectly. Now if I go for increment from there, actually let's go for decrement. Decrement and latch. Those are not, the decrement is not working. If I go with increment, which is 2, so load, latch. All right, let's get the logic probe back out again. So that's correct, but it's not actually incrementing. All right, I gotta walk away from this. Okay, couple of things here. I did end up having a bad switch here, so replacing that ended up getting proper connections. It was spotty at best otherwise. And then this resistor, I had a 1K resistor in here. I replaced it with a 220 ohm resistor, and that allowed the current to flow through the way it needed to and then pass on to the reset line properly. So I got those two fixed, and this is now working a little bit better. I'm going to go through another round of testing on this just off camera just to make sure, and of course I'll come back and tell you if I find anything. But it's working. I didn't have to make any changes. Now, that said, I do have a problem here and here. These are in reverse order, and that is going to cause me to have to redo this PCB order, and the others end up being just trash, unfortunately. So I am going to work on getting this cleaned up and make sure that this is working now properly, or at least you get it cleaned up and get it ready to reorder. And then with that, the follow-up question then becomes, how far do I take the testing on this? I know I have problems. But so for example, the 409 6-bit, I believe it was not turning on when it should have. Do I trace down all the solder problems here? Or do I just simply cut my losses and solder up a new breadboard when everything comes in proper? I think I could use the practice, and I think I'm going to go through the troubleshooting on this. And so then the question becomes, do I do the troubleshooting on camera? Or do I do it behind the scenes and then report back what I found? I'm going to think on that question. I got to tell you, I'm feeling quite defeated at this point. I'm not giving up, but I am feeling defeated. And I did want to come back and redo I didn't like the fact that the silk screen on this wasn't right. So I would not feel bad in redoing that and fixing the silk screen here. So I am definitely going to redo that. I was kind of looking for a reason to, but I do think I need the practice of troubleshooting the boards and trying to figure out exactly what's going on. Now, most of the components on this, particularly the 138 here, I don't have a lot of duplicates of. So I will probably end up making an effort to pull the ICs off and salvage them. And same thing with the headers and the sockets and all of that. So I think I'm going to go through the trouble of troubleshooting this as I'm thinking on camera, go through the troubleshooting process on this, make sure that I can get as much of it cleaned up as I possibly can. I don't believe I want to go through the effort of bodging this. And the reason is that may require some changes to some of these ICs because it's all backwards. So I may go through the trouble of trying to correct this solder and make sure that all my solder joints are proper to make sure that I get the right value out, and then understanding that as I increment and decrement, these are going to be incorrect here. Yeah, very deflated. Well, while I assure you I'm not giving up, I will tell you that this does sting a little bit. I am going to go through and troubleshoot the rest of this particular PCB and identify all the different issues, get those all sorted out, and make an effort to make sure that this is actually working properly the way it's supposed to. And once I have all the issues identified and everything that I need addressed in the schematic, and then I'm going to go ahead and order a replacement PCB. There's no point in doing that until I know I have everything working properly. At the same time, I'm going to go through my breadboard version and reconfirm for myself, because I've lost a little bit of confidence here, reconfirm for myself that everything is actually working the way I expect it to. And I know it's painful to watch, but you know, maybe like watching train wrecks, because that's kind of what I feel like I'm recording right now. Anyway, thanks for your time, and I'll see you again soon.